All right, we are going over worksheet 55 to prep it and have you guys get moving. The front side focuses on 30, 60, 90s, and the back side focuses on 45, 45, 90. So these are not mixed up, but there's a little bit more to them. So looking at the front, I'm not going to start with number one because you have the short leg. I do know it's the short leg because it's opposite the 30 degrees. I'm going to remind you again, there's always 180 degrees in a triangle. Take off 90, take off 60, there's 30 degrees left. So you should know which one the short leg is. This is the long leg, and this is your hypotenuse. The reason I'm skipping over that one, so numbers 1, 2, and 3, 4, they all give you the short leg. Let's jump to number 5. And the reason I want to jump to number 5 is because they give you the long leg. All right, how do I know this is the long leg? Because it's opposite 60 degrees, and this is the short leg. So let's just take a second and label it. So I'm going to use my sheet, all right, and then on my sheet I have that extra labeling. Short leg is just x, the long leg is x squared to 3, and the hypotenuse is 2x. So I have a star here because everything's based off the short leg. Now, if we know the long leg right here, if you know the long leg, find the short leg by dividing by the square root of 3. So if I know this, I have to divide the square root of 3 to get rid of it to get x by itself. So you're literally going to take the 12 and divide by the square root of 3. Now, it's not proper to leave a square root in the denominator, so you typically have to do this thing called rationalizing the denominator. We're not messing with roots right now. We're going to do that as a separate lesson. So you're going to take your calculator, and you're going to take 12, and you're going to divide by the square root of 3. And please get in the habit of closing your parentheses because it does make a difference on some problems. So we get about 6.9. So let's go nearest 10. So x is approximately 6.9. Now everything's based on that short leg. So now that I know this short leg is about 6.9, I can find the hypotenuse by taking x and doubling it. There it is. If I know the short leg, find the hypotenuse by 2. Multiply by 2. So take what was in your calculator, that 6.9, and multiply it by 2. So I'm just going to take my answer and multiply by 2. And that's 13.9. Now, if I rounded earlier, I might get a little bit different, but we should be very close. And there are my two sides. Okay, I want to jump down to number, let's do number 9. In number 9, you have a large triangle and it's cut. So I'm actually ignoring this. But this is 90, there's 60, and there's 30. So I'm really focusing in here on just this triangle to the side. So I can ignore the other half of that. So if I have the hypotenuse, this is your hypotenuse, I need to go to the short leg. So let's look at our paper. The short leg is x, the hypotenuse is 2x. So to reverse it, no hypotenuse, find short leg, divide by 2. All right, well, I can do that. 16 divided by 2, that's 8. So x is 8. Now, I know the short leg. That's what everything's based off of. So this guy is 8. To find the long leg, know the short leg, find the long leg, multiply by the square root of 3. So this would be 8 square roots of 3. So you could write y equals 8 square root of 3, or you could type it in the calculator, 8 square root of 3. Close the parentheses. Oh my. And we get 13.9. All right, so that's all you're doing there. I want to talk about this bottom piece here. You have number 10. It says an equilateral triangle. What do we know about equilateral triangles? All right, so all three sides are the same, right? What about the angles? They're all the same. There's 180 degrees divided evenly. Each angle is 60 degrees. Okay, and it says the length of one side is 10 inches. So I'm going to put 10 inches around all of these. I think drawing a picture is really helpful for my brain. It says find the length of the triangle's altitude. Okay, altitude was the height from the top of the triangle vertex dropping to the other. It's important this is an isosceles triangle or equilateral because when I drop this, it bisects it. So this is equal to this. This makes a angle bisector. So now this is 30 and this is 30. So why am I showing you this? You honestly have the same triangle right here. That's 60, 60, 60, and that comes down. We think this could be the same one. Not 100%. This could be a different angle, but this is 60, 90, 30. Then this is going to have to be the same. Maybe not. Maybe I'm lying, but that is a 90 there. So if we look at this, guys, and the whole length is 10, wouldn't this side be 5? So can you see this triangle here? This is 10, this is 5, and I'm trying to find this. Now, honestly, you could use Pythagorean theorem also. A squared plus b squared equals c squared, but that's going to take you more time. So what I'm going to do is know that this is 60 and that's 30, and I could use Pythagorean theorem, but since it's a special right triangle, I know the short leg, I'm going to find the long leg. So short leg to long leg, square root of 3, multiply. So it'd be 5 square roots of 3. That's a good answer, or you could do 5 square root of 3 in your calculator, and I get that 5 square root of 3 is approximately 8.66, so 8.7, and we would say inches. That is the altitude. Now, I knew that this was 5 because I knew that this cut it in half. You also could have found it by taking half of the hypotenuse to get that. So now the next one I'm not going to do for you, but you also says the altitude of an equilateral triangle is 18 inches. Find the length of a side. So I'll set it up for you, but I'm going to let you do the math. The altitude is 18. We have that same idea of a 60, 30, 90. So if you pull your triangle, you have the long leg. You need to find the short leg and the hypotenuse. So it says find the length of the side. This would be the side. So you're going to have to find the short leg, but this hypotenuse would be the side. Okay, so that's it for that side. Let's flip it over and talk about the 45, 45, 90. I think the 45, 45, 90 is a little bit easier because you have two equal sides. Now, this one, and I wasn't paying attention, I guess it gives you a little thing. The hypotenuse equals the leg times the square root of 2. And the leg equals the hypotenuse divided by the square root of 2. So they have the rules right here for you also. And so they're showing you here on your 90 degrees, you have your legs, 45, 45, and these are little arrows saying this is your leg, hypotenuse is your leg, hypotenuse, take your leg times the square root of 2. So it'd be leg times square root of 2. So that's a little thing there. All right, so looking at this one, if I know that these base angles are the same, then it's an isosceles triangle, and these two sides are 8. So how do I find the hypotenuse? I take the leg times the square root of 2. So x is 8 square root of 2, or x is approximately, I don't know, I've got to use my calculator. Put it in, 11.3. And I would take either. Okay, so we've got a bunch of legs here. Number 3, do you see that this is a square? So all the sides are 18, but that's not the big deal. If you can just picture that right triangle, you're trying to find the hypotenuse. Now, let's talk about number 6. If you can focus on the triangular part, half of the square, they give you the hypotenuse, you need to find a leg. So if you look at your rules with your 45, 45, 90, the legs are x, this is x squared of 2. So if I know the hypotenuse to find the leg, reverse it, divide by the square root of 2. So I would take 10, divide by the square root of 2. So x is approximately 10 divided by square root 2. It is approximately 7.07, so 7.1 units. Okay, let's talk about a word problem down here. It says the perimeter. Okay, what's perimeter mean? And it's of a square. What's perimeter mean? Yeah, if we walk around it, the sum of the four sides, the distance walking around it, And we know a square has 4 equal sides, right? So to find the side, wouldn't I take 48 and divide it by 4? So each side is 12 meters. Well, there you go. We just did half the problem because you had to set it up on your own. And it says find the length of diagonal. Well, there you go. Look at it as a triangle now. If you have a square, you know that's 90. And if you split a square across the diagonal, you bisect the 90-degree angle. So there's your 45, 45, 90. So this is only going to work with a square, not a rectangle. And then you're supposed to find the diagonal. So I'll call that x. Same idea here in number 8. And then down at the bottom, it asks you to find x and y. But if these are all 45, 45, 90s in the first three, whatever x is, y is the same. Now, when you go down to 12, 13, and 14, they do change these to your 30, 60, 90. So you'll have those two different numbers. So this bottom one is a little mix of both. Okay, so that's it for the worksheet. I guess I totally skipped over this, but on the front, they're showing you the rules. If you have the hypotenuse, it's twice the short leg. The long leg is a short leg times the square root of 3. And they have this picture. And again, these are arrows. It's not that the triangle's cut off. It's saying short leg times 2, short leg times the square root of 3. All right, guys.